Hey everybody, this is Larry. This is day 7 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Add two numbers. 2. You're given two linked lists and you have to add them, okay? Whatever you cannot modify the input list. In other words, reversing the list is not allowed. Okay, yeah, I was gonna do reversing. It's usually a lot easier if you're able to. But I mean, I think the annoying thing is just that it is annoying, right? This is a linked list problem, and if you watch me enough, you know that I don't find linked list problems that interesting. It's usually just a lot of edge cases, but it does come up on interviews, so you know you should practice enough, at least on the problem solving, so that you know how to do it. Yeah, in this case, I don't think there's anything mathematically difficult or tricky thing for me to explain. It's just a lot about being careful and also just, you know, like taking care of the edge cases, and that's what being careful means. How do I want to do this? How do I want to solve this? It's annoying either way. I think I mean, and you know, I'm going to do it in a couple of passes. Everything's going to be linear. It'll be okay. But we'll do it in a couple of passes where, yeah, and we'll just get the length of the things, right? So n is equal to get length of L1, m is equal to get length of L2, and we have to write the code for get length of a node. So count is equal to if node. I'm just going to write it recursively because I'm lazy. Though it's going to incur some space, but that's okay. And then now that we have the length of the two things, now we can match them up, right? So then we just have to skip the min a little bit. And I'm going to do a quick thing where if n is bigger than m, we swap them. And this is not that interesting or necessary. It just makes it easier to kind of handle the edge cases, because then now instead of the edge cases being together, now we could decouple them so that you know you can handle them differently, because from now on we know that n is going to be e less than or equal to m, right? So now that this is our thing, then we can kind of solve the problem slightly easier, a slightly easier version of the problem, though this may be true. Nope. So then now we have to figure out the offset is equal to m times m minus n. We move let's just have a helper function, and you can write this a lot of different ways. You can write them with while loops. I usually actually write them with while loops, but today I'm going to write them recursively just to kind of practice recursion a little bit, because it's been a little bit. Yeah, so let's just add two numbers. We have L1, L2, and then an offset, say. If offset is greater than 0, then add two numbers of L1.next, L2, offset. We need to return the result. I'm just gonna, I'm a little bit lazy, so I'm just gonna return the results in L1, say, and maybe that'll be okay. Yeah, so L1 is the smaller one, so we got it mixed up, or I got it mixed up. Speaking for ourselves, because L2 is the longer one, right? Because of the precondition. So yeah, don't know why my voice is a little bit weird today. Maybe I just didn't sleep that well. But yeah, so now we offset by 1. So yeah, also return. And now that the offset is the same, then we can just add L2 dot value plus or equal to L1 dot value, right? Well, but first let's add two numbers of L1 next, L2 next, offset, right? And why do we want to do that? And of course, we should check that if L1 is none or L2 is none, return add two numbers is equal to this. So now we want to do it the way that I'm going to do it is going to do it backwards by using recursion, because then now we have this thing and we add them together. And then now we go, and so basically what I'm doing here now is, for example, we add the 3 and the 4 first, and then the 4 to the 6 second recursively. And so that now we could tell that this is a 10 and then do the carry. So that's basically my idea. And then, so carry is equal to L2 dot right is equal to 0 if L2 dot next is not none and L2 dot value is greater than or equal to 10. L2 dot value subtract 10, carry is equal to 1, we carry the 1, right? So now we just have to add L2 and offset, and that should be okay, except for the case where we have the carry bit in the beginning. So yeah, so we're going to have to take care of it, but I'm going to just test this right now just to make sure that you know, it's almost like TDD, and that if I test it now, I could, you know, see if it's correct, and if it's not correct, then I could debug what I have now. Versus if I keep on adding new functions and stuff like that, and when things goes wrong, there are a lot of places to look, right? And besides, the only thing that we don't do right now is just carry the 1 in the beginning. So we should be able to do that very, check very quickly, hopefully. Yeah. Okay, so we definitely messed up something over here. Oh, whoops. This is that next dot value, of course. See, now I don't have to worry about, you know, other things. Okay. Oh, why did I do that? I think that was just a brain fart typo. Okay, so this looks good. This doesn't look good, but it, like we said, right, I know that this wasn't going to be good for this case. That's why I put it in there. I just kind of put it in there to remind me, but also knowing that, but this is what I would have expected if that was the case. But yeah, let me actually add a couple more first though. Some basic things. Also making sure that they're symmetric. It should be, because it is a very trivial check, but you never know. So that's why I want to check that. Yeah. Did I miss the... That's interesting. Because we definitely, the carry definitely happens here on the first problem and the second, well, this one doesn't do anything. I'm not sure why this doesn't get carried forward. Oh, no, this is right. I mean, this is expected. It's just that, I mean, the code is doing what I told it to do, but it's not 100% yet. And that is that because of the offset, we don't look at the nodes if it's not an offset. So actually, we have to add some code here as well. Right. So now that the offset is 0, let's check again. Maybe we could dry ourselves a little bit, but for now, let's focus on getting it right. So this is carry, it's just L2 dot value is 1, right? Cool. So this is now what we expect a little bit better. And then at the very end, we can just check if L2 dot value is greater than or equal to 10. And again, yes, some of this is a little bit hacky, to be honest. But new head is equal to, what's it called, list node of 1, new head dot next is equal to L2, return new head. Right. I mean, this is a little bit hacky. We could definitely figure a way to clean it up, but now you can kind of see how I break it down different pieces and do it one at a time. And that said, these things, and that's why I find it annoying, is that you never know. Well, not you never know, but I feel like I'm never confident about it, however. And yeah, I mean, this looks okay, so I'm gonna submit, but I wouldn't be surprised if I get a wrong answer, but okay, that's good. Yeah, so what is the running time complexity? So the running time is going to be O of n because we look at each node once or twice or something like that. But the space complexity is going to be O of n because we essentially use the stack as we use the core stack as an implicit stack to kind of push things on top. So linear time, linear space. It's a little bit messy. We can definitely try things up here. We could figure it out how to do that at some point, but yeah, and there are ways to do it, but I'm not going to do that here. You can upsolve it at home if you like. Let me know what you think. Let me know how you did. Let me know if you like these linked list problems. I try don't be okay, but yeah, I will see y'all tomorrow. Bye bye.